Alright, so these are your notes for section 1 of chapter 7 for chemistry. You already got these notes the other day. We talked about the chemical formulas, but now we need to talk about determining the formula for an ionic compound and or naming an ionic compound given its formula. So we're going to get through essentially these second two objectives today, and we'll continue later Monday. Okay, so we talked about chemical formulas and formula units. Right? We know that a formula indicates the relative number of atoms of each kind of element in a chemical compound, and we know that if it's a metal and a nonmetal, if it's an ionic compound, we're going to use the simplest ratio for that formula unit. We are going to reduce. Okay, so for our ionic compounds, in order to name them, right, we had to learn some monatomic ions. We had to learn ions formed from a single atom. You have most of these memorized by now. Hopefully, we're talking sodium, magnesium, aluminum, oxide, fluoride, chloride, right? Whatever. So these are some of those flashcards that you've been using trying to memorize these things. If it's a monatomic ion, though, the charge should be easily predicted for main group elements, not so much for the D block elements, but those are the ones that you have to memorize for sure. Remember, anything that's a D block element, it is likely that it's going to have a +2 charge, but that's not a guarantee, right? Because remember, a lot of those options, copper, iron, they have two options. One of them is a +2, but the other one's different. So those are ones that you just kind of have to memorize. But pretty much every time, if it's main group, you'll know what it is, what charge it has. Aluminum is found in group 3, so it has a +3 charge, right? Oxygen is in group 6. 6 valence electrons means it can gain 2 to be full, so it's going to have a -2 charge. So those ones you can typically look up using your periodic table, but if it's a D block element, sometimes you just got to know. Okay, so we're focusing on naming binary compounds, compounds composed of 2 elements. So it says no polyatomic ions, initially at least. For ionic compounds, the cation always comes first. Followed by the anion. For covalent compounds, the least electronegative element comes first. We'll come back to that later because we're not really going to talk about naming the covalent compounds right away. But at least for right now, we should know that it's aluminum oxide, not the other way around. Right? The aluminum has to come first because it's the positive cation. Remember when we talked about that before, you remember which one's which. Cat has that T in it. Those are the positive ones. Anions are negative. Our nomenclature for ionic compounds, that's just your naming system. We're going to start out by identifying the cation just with the element's name. Stock names might be necessary if there's more than one charge, remember, because I can have iron 1 or iron 2 or iron 3. Excuse me, iron 1 doesn't exist. Sometimes we're going to use some old names, remember, because I could also call the iron 2 ferrous, iron 3 is ferric. Anions are named by dropping the ending and adding an IDE to the root name, and then every once in a while I'll throw in those polyatomic ions, and those could be positive or negative. A lot of them are oxyanions because they contain oxygen. Remember when we had phosphate, sulfate, a lot of those different, nitrate, they all had oxygen in them as well as some other element. Those ones, remember, you just kind of have to memorize them, otherwise you're not going to know what they are. So you got to get to work with your flashcards and know your polyatomic anions. But as far as the actual work goes for this, it's really kind of simple. Right? We've already kind of talked about examples for these things, but we need to be able to write a formula from the name for a binary ionic compound. So if I'm given this name magnesium iodide, I have to be able to come up with the formula. So first I have to know that magnesium has this symbol and it has this charge. If you didn't know that, you could use your periodic table. So that's one that you don't necessarily have to memorize, but it's helpful if you do. Right? Iodide. Right? That's just an iodine with a charge. So my symbol is I, and my charge is -1 because it's a halogen. And then I just put that information, I use this information, I use those charges to determine how many of each element I need to make this thing neutral. I talked to you already about taking those charges and moving them down and making them subscripts. Right, so that my magnesium iodide turns into this formula. I need 1 magnesium for every 2 iodines. So that would be my final answer for that formula. I have all these other examples here to go through. Just go through each one. You'll have some practice at the end of this, but just kind of follow along as I go so you can see how this works. Potassium sulfide. Potassium has this symbol and has +1 charge. Sulfide. It's a sulfur with a -2 charge. It's like oxygen, it needs to gain 2 to be full. So it gets that -2 charge. I cross those 2 numbers, and I need 2 potassiums to balance out a sulfide. So that's my formula. Right, this next example, copper 1 oxide. If you're given a stock name, that makes things easier because you know that this copper is the +1 version because they told you it's +1. They say copper 1. That Roman numeral just gives you the charge. So copper oxide, I just need to know my 2 ions. I cross those numbers. I can see here that I'm going to need 2 coppers for every oxygen to make that formula. Back up to the top over here, aluminum chloride. Aluminum has a +3 charge. Chlorine has a -1. So again, you cross. I need 3 chlorines for every aluminum. That's going to be my formula. Calcium nitride. Calcium is a +2 charge. Nitride, the -3 charge. Cross those. I know I'm going to need 3 calciums. Whoops. And 2 nitrides to make that neutral. Stannous oxide. Again, sometimes you're going to have to recognize some old names. The symbol is easy to come up with from an old name because that's where it actually comes from. But tin, which version of tin is this? There are 2 different versions of tin. There's 2 and 4. So there's a +2 and a +4. Us is always the lower of the 2. So I'm going to say +2 here. Oxide's a -2. And I can move those 2's down, but ultimately they're going to reduce. I'm just going to need 1 tin and 1 oxide for my formula here. So again, hopefully you can follow along and see how that works. It's a lot easier if you can just come up with those ions without having to look them up using a list. So hopefully you've started to memorize those. But here's our other scenario. sometimes you're going to have to name the ionic compound given a formula. And really, this is the easier of the two things that you need to be able to do. All you have to do is recognize what it is half the time, so you don't really need to care what the charge is. You just need to know what it is. So in this first case, as soon as I see that Ba, and as soon as I recognize that that's barium, I have my name. I have barium, and then in this case it's fluoride. You take your fluorine, drop the ending, and add IDE to the end. So it's barium fluoride. The next one, calcium oxide. As soon as you recognize your elements, you're good to go. The next one is actually cobalt iodide. Now this is a tricky one. This is where things get a little bit messier. Cobalt has two different options, if you remember, when you've been going through your flashcards. It could either be a cobalt 1, excuse me, let me check real quick, because I'm pretty sure I was wrong there. It can either be cobalt 2 or it can be cobalt 3. So I'm looking at this formula right now, and I can actually tell which cobalt it is. I just have to think backwards from what we were doing before. This 2 here with the iodide can be moved up more or less to give me that +2 charge. Now you have to be careful when you do that, because that would only be appropriate if I can move this understood 1 up here and make that -1 charge correct for iodine. Because remember, some things get reduced every once in a while. But in this case, iodide does have that -1 charge, so this is cobalt 2. I don't have to worry about unreducing this one, but sometimes you have to be careful. Okay, so my next example over here at the top, as soon as I recognize it, I got a name. That would be silver fluoride. The next one, I don't know why I wrote a K down. I know exactly what that is. It would be potassium nitride. Sometimes my brain gets ahead of me and I'm not even thinking. Last one down here. I know that that's a lead sulfide. But again, I have to figure out which lead it is, because you just have to know when you hit iron, lead, tin, cobalt, copper, mercury, there's always 2 options. So you have to look, you have to check to make sure. If I move this 2 up, it could be lead 2, but then remember I told you to check every time. I'd also have to assume that sulfide had a -1 charge, and that's not true. Sulfide should have a -2 charge. So if I have to double this to make that charge correct, I'm gonna have to double this charge. I should figure out that this is lead 4. It just got reduced when you made that formula. Because remember, if I started out with lead 4 and sulfide, I try and move these numbers, but that 4 and that 2 are going to reduce. So it turned into 1 lead, 2 sulfurs, 2 sulfides. But it was that lead 4, not lead 2. And again, in this case, unlike the cobalt, there is an old name if you want to use it. This could technically be called plumbic sulfide. So use one name or the other. You can use the stock name every time if you want, because it is actually easier. But ultimately, just need to name it. So use whichever one you want. If you like the old name, use the old name. Okay, so for these formulas and names, we're supposed to be incorporating polyatomic ions. And the only new thing here is, like I told you before when we were building formulas, you have to use parentheses when appropriate. Since nitrate is a thing, NO3 with the -1 charge, you have to keep that thing in parentheses to make sure that it doesn't end up changing, right? So again, I did have a -1 charge, and I got a copper here with a +2 charge. I'm going to take my 2, move it down, and I can see that I'd need 2 nitrates to go with 1 copper 2 with that cupric ion. But again, I needed parentheses to make sure that I didn't screw things up. All right, next one. Sodium hydroxide. In this case, sodium has a +1, hydroxide is -1, so they are already balanced. I don't have to do anything. So I'm just going to write sodium, write hydroxide, and I'm done. Ammonium acetate, same thing. They're 2 different polyatomic ions, ammonium NH4 with a +1 charge, acetate C2H3O2 with a -1 charge, +1, -1 balance out. I don't need parentheses, but it certainly wouldn't hurt you to put them in there. So if you put parentheses in there just to keep things separated, it's fine. You just don't need those. This next one though, calcium carbonate, right? Don't have +1 charges anymore. This time I have +2 charges, but they're both the same. And I got a +2 and a -2. They balance out, so there's just 1 calcium for every carbonate. This one's done as is. I don't really need the parentheses, but sometimes it's good to put them in initially, and then eventually you find out, okay, I don't need parentheses around hydroxide, but it doesn't hurt me to put them there. Now on the right, coming up with names, this is sodium, and the other thing that I see there is called either hydrogen carbonate or bicarbonate. I will almost exclusively use that bicarbonate, so remember, you're supposed to remember that name as well. I almost never call that hydrogen carbonate. Just never have, probably never will. So this might be the only time you get to hear it that way. This next one is obviously a cobalt hydroxide. But which cobalt? Again, just move charges, move this number back up where it belonged from before. And as long as hydroxide is -1, which it is, cobalt, this version is cobalt 2 hydroxide because that's a +2 charge. This next one is an iron sulfate, as you can see. But again, I got to figure out which iron. If I move up that 3, it's a +3 here. The 2 gives me a -2 over here. Sulfate does have a -2 charge, so this is iron 3 or ferric sulfate. And then finally, this last one down here. Is a mercury nitrate. I know it's mercury nitrate, but which mercury is it? this is one of those ones that you just have to see and you got to be careful. Right? If I move the +2 up here, that's good and great. But I got to remember that sometimes the mercury is polyatomic, sometimes it isn't. In this case, if I move that 2 up here, I'd have a -2 charge for my nitrate, but that doesn't make sense. My nitrate has a -1 charge, which means this 1 is, or this 2 is supposed to stay where it is, which actually tells me that this is mercury 1, not mercury 2. Now that's just something that you have to work with to recognize, but a lot of times that mercury is kind of tricky. Usually if there's a 2 there, you're not supposed to move it. So don't even think about moving it. So you got to recognize that mercury is a little bit weird. It always has a +2 charge, but is it polyatomic or not? This is mercury 1 because 2 divided by 2 is 1. So hopefully walking through those examples, you guys kind of know what's going on. You're going to get a worksheet here that you need to get through. Just do the best that you can. Try to do it without using a list, but if you need the list, ultimately you got to use the list, right? You got to know the names of these things and the charges for these things before you can do it right. So hopefully you're working on memorizing those, but you do what you do. All right, so that's all we can do for today.